This is section 8.2, trigonometric ratios. These are the objectives. You can pause to read them. I'm moving on to the vocabulary. The same thing, pause to read them. Let me just say something. For this section, you're going to need a scientific calculator. If you don't have one, don't worry. We have one in class. Just take good notes, and then we can clarify those concepts that you need the calculator for in class. But make an effort. You can go online and Google scientific calculators, and you should be able to have access to one. Let's move on to the next slide. Very important definition here on this slide. Definitions, actually. These are the ones that you're going to be working in this chapter. Sine, cosine, and tangent. You can go ahead and read this. I'm just going to focus on this. Okay. Notice that we have right triangles here. It says the way that we read this, sin is not sin, is sine. Cos is not cos, is cosine, and so forth. Okay. So now, notice that they have sine of angle A and sine of angle B. Let's focus on the first one. Sine of angle A, by definition, is opposite leg over hypotenuse, which is a ratio. So I'm here, and this is my angle, what we call the reference angle. From this angle, which leg is opposite to it? This one, A. And which one is the hypotenuse in this right triangle? C. That's what we have, A over C. Let's go to cosine of angle A. Different definition. Cosine of angle A is adjacent leg over hypotenuse. So I'm at angle A. The adjacent leg is the one next to the angle, B here. And then C is still the hypotenuse. That's what we have. Cosine of angle A is B over C. Tangent of angle A, by definition, is opposite leg over adjacent leg. So again, I'm still working with angle A. Which leg is opposite to angle A? Little a. Which leg is adjacent to capital A or angle A? B. That's why the answer is A over B. How do I get these other three ratios? The only difference is now that I have a different reference angle. I'm looking at the triangle from this angle now. So let's focus on sine of angle B. By definition, is opposite leg over hypotenuse, excuse me. So if I'm here, which leg is opposite to angle B? This one. Which one is the hypotenuse? Has not changed. That's why it's B over C. That's why we have B over C. How do we cosine of angle B? The same way. By definition, this is cosine, adjacent leg over hypotenuse. So if I'm here, which leg is adjacent to it? A. And what is the hypotenuse? C. And again, it has not changed. That's why we have A over C. And you should be able to see why we get it. Tangent of angle B is B over A. Let's move on to the next slide. I am going to help you with the following so you can memorize these three definitions. So we call it acronym, abbreviation form from the initial letters in a phrase. Copy this. It says so, ka, toa. What does this represent? It represents the following. First, let's sketch the following right triangle so you can see a little bit better. So stands for SOH, sine opposite hypotenuse or opposite leg hypotenuse. So if you go to if you want to compute just using this triangle, sine of angle A, and again the opposite leg is little a, the hypotenuse is still C, so that's why you have A over C. Ka stands for cosine adjacent leg over hypotenuse. And if you compute cosine of angle A in this right triangle, is adjacent leg, which is here, over the hypotenuse. And toa stands for tangent opposite leg over adjacent leg. So if you compute tangent of angle A is opposite leg to angle A, which is A, adjacent leg is B. That's what we have this. Hopefully this will help you remember the three the three trig ratios that we'll be using in this chapter. Next slide. Number 1 says write the trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth. Again, you need a calculator for this part. So I need to compute sine of angle J. Here's where I have angle J, so I'm going to be looking at this right triangle from here. Let's use the acronym. So this stands for sine opposite over hypotenuse. So that's why I have this. Sine of J is opposite over hypotenuse. If I'm at J here, which side is opposite to angle J? 60. And which one is the hypotenuse? This one. The hypotenuse is not going to change in this right triangle. Hypotenuse is always going to be 61. So then you do 60 over 61, you punch that into your calculator, and you need to run to the nearest hundred. That's how we get 0.98. Now let's do cosine of angle J. So cosine is adjacent over hypotenuse. And again, we're still working with this reference angle J. So from this angle, which side is adjacent to it? 11. And then the hypotenuse is still 61. So that's why we have this. Punch this into your calculator and you get 0.18 once you round to the nearest hundredth. Now tangent of K. So now we're looking at this being our reference angle. Tangent is opposite over adjacent. So from here, which side is opposite to K? 11. Which one is adjacent to angle K? 60. That's why we have this. Punch it into the calculator and you get the following. Let's move on to number 2. Very similar to number 2, same directions. Now I want to compute sine of B. Let's bring the acronym, SOHCAHTOA. So here's my reference angle, angle B. Sine is opposite over hypotenuse. From this angle, which side is opposite? 24. Which is my hypotenuse? This one is never going to change. That's why I have the following. Cosine of angle A. So now this is my reference angle. From here, I want cosine adjacent over hypotenuse. So which side is adjacent to angle A? 24. And again, the hypotenuse has not changed, which is still 25. That's why cosine of angle A is the following ratio. And once I round, I get the following. Notice it is the same ratio for sine of B and cosine of A. And this happens. Tangent of B. So now, this is my reference angle. Tangent is opposite over adjacent, opposite side, adjacent side. That's why we have this. Once I round, this is my answer. Let's move on to the next slide. It says use your calculator to find the trigonometric ratio. So you want to punch in sine into the calculator and then 5.2. Once you do that, you should be able to see this on your screen. 0.78 and then all the numbers to the right of the 8. What happens if you don't get this number? This is why. Because your calculator is not in degree mode. It's probably in radian mode. If this is what your calculator is showing, 0.986 and so forth, that means that you're in radians. And you need to change it to degrees. If you do not know how to do that, talk to me and I'll show you how to do that on your calculator. Let's move on to number 4. Same directions. Cosine of 19, make sure that you're in degrees. Once you round, well, this is what you get on the screen on the calculator. But once you round, you say 0.95. Tangent is 65. Punch it in, tan, and then 65, and you should have that. Once you round, 2.14. Next slide. Here's number 5. It says find the length BC, round to the nearest hundredth. This is going to involve some algebra, so you should feel comfortable with this. If you need some review, talk to me in class. So this is what we're looking for, this side, BC. So what we're going to do is we're going to use the trig ratios. Okay, so then this is what I'm going to use. Since I know this opposite side to angle B and I'm looking for the adjacent side, I am going to use tangent of the reference angle that I'm giving here, 15. And definition of tangent is opposite over adjacent, AC over BC. And then at this point, what I'm going to do is I'm going to substitute the given information. So B is 15, AC is 10.2. This is what I'm looking for, BC. At this point, I know that this is a proportion. Fraction equals fraction. I am going to cross multiply, and this is what I get. At this point, I am going to solve for BC. To do that, I need to divide both sides by tangent of 15, and that's how I end up with this. Once I do that, this cancels out, and I'm left with B is equal to this. At this point, I pull out the calculator, divide 10.2 by tangent of 15, and this is my answer. Just read the following, please. Be careful with this. Let's move on to number 6. It says find the length QR. So we're looking for this here and round to the nearest hundredth. Just very similar to number 5, but now we're going to be using a different trig ratio. Notice that this is my reference angle, 63. This is the hypotenuse, and this is this side, QR, is opposite to the angle 63. So what trig ratio is that? Is sine. Sine of P is equal to opposite leg over hypotenuse, or QR over PR. I substitute the given information that I know. I know that P is 63. I know that, our PR is 12.9. And then at this point, again, this is over 1. Cross multiply. I get the following. At this point, I don't have to divide anything. I just need to punch this into the calculator. 12.9 times sine of 63. And this is what you get for your answer. QR is approximately 11.49 once you round to the nearest 100 centimeters. Next slide. Here's number 7. It says find the length FD, round to the nearest 100, same directions. So to find FD, which is this, your hypotenuse, I am going to use cosine. Why cosine? I know this reference angle, I know the side adjacent to it, and this is the hypotenuse. Adjacent, hypotenuse is cosine. At this point, all I'm going to do is I'm going to substitute the values that I know from the right triangle. So I know F is 39, I know EF is 20. At this point, I know I can cross multiply. I get the following. Then divide both sides by cosine of 39. Punch this into the calculator, and I get my answer. 27.74 once I round to the nearest 100. Let's move on to number 8. Last one. It says find the length D, hundredths. So this is D, excuse me. So then from here, what I'm going to do is I'm going to use tangent. Why? Because given this reference angle, I know the opposite side. I'm looking for the adjacent, and that's the definition of tangent, opposite, adjacent. Substitute the values. D is 51, EF is 17. Do a little bit of algebra here. Once I cross multiply, I get this. Divide both sides by tangent of 51. This goes away. And I end up with D equals 17 over tangent of 51. At this point, punch that into the calc, round, and here's your answer. This is meters. This concludes the video.